Welcome to the DIY Honda Garage channel. The Honda Pilot, manufactured between 2016 and 2022, may encounter a diagnostic trouble code, or DTC P0453, which refers to a high voltage reading within the fuel tank pressure, or FTP, sensor circuit. This sensor is a vital component of the evaporative emissions control system, designed to monitor the pressure inside the fuel tank. A high voltage reading can indicate that the sensor is either faulty or that there's an issue within the electrical circuit. Understanding the implications of this error is crucial for effective troubleshooting. If this DTC is confirmed, it often suggests either a problem with the sensor itself or an associated wiring fault. Addressing this issue promptly is essential for maintaining vehicle emissions standards and ensuring optimal engine performance. The fuel tank pressure FTP sensor is an integral part of the evaporative emissions EVAP system in the Honda Pilot. Located near the fuel tank, it measures vapor pressure and helps ensure that fuel vapors do not escape into the atmosphere, thereby maintaining vehicle emission standards. A high voltage signal from this sensor, as indicated by DTC P0453, suggests an anomaly in its operation. The sensor communicates with the Powertrain Control Module, PCM, to manage fuel vapors effectively, and if it reads above the normal threshold, it can create diagnostic trouble codes. This indicates that it may require validation during troubleshooting to ensure accurate readings and operational integrity. Several factors could trigger DTC P0453, necessitating thorough investigation. A faulty FTP sensor itself is a primary suspect, as it may provide incorrect voltage readings due to internal malfunctions. Another possible cause could be wiring issues within the circuit connecting the sensor to the PCM, including frayed wires or poor connections that disrupt signal transmission. Additionally, loose or corroded terminals at the FTP sensor or the PCM could contribute to voltage discrepancies. Understanding these possibilities is essential for accurate diagnostic procedures. Addressing these potential causes systematically can lead to pinpointing the underlying issue swiftly and effectively. Several symptoms can accompany DTC P0453, helping to identify the issue during the diagnosis. The most common indicator is the check engine light, CEL, illuminating on the dashboard, which signifies that the onboard diagnostic system has detected a problem. Additionally, the driver may experience poor engine performance due to improper fuel vapor management, which can manifest as poor acceleration or stalling. Increased vehicle emissions might also be a concern, as an unresolved FTP sensor issue affects the efficiency of the EVAP system, resulting in excessive harmful emissions. Being alert to these symptoms is vital, as they can impact vehicle performance and compliance with emissions regulations. For the initial troubleshooting step for DTC P0453, start by turning the vehicle to the on mode without starting the engine. This allows the vehicle's onboard diagnostic system to engage. Use the Honda Diagnostic System, or HDS, to clear any existing DTCs. After clearing codes, turn the vehicle to the lock mode to ensure a full reset. Then, insert the emergency fuel funnel to check the fuel tank pressure. Following this, turn the vehicle back to the on mode and monitor the values from the FTP sensor against the prescribed thresholds for your model year, which is more than 4.7 V for 2016 to 2017 models and more than 27.23 millimeters Hg for 2018 to 2022 models. Matching current conditions with these thresholds is crucial for determining whether further steps are necessary. In the second step of troubleshooting for DTC P0453, verify whether the problem persists. Begin by ensuring the vehicle is in the off-lock state. Then remove the emergency fuel funnel from the fuel filler neck. Start the engine and hold it at an elevated speed, specifically 3,000 RPM, without any load on the engine. This can be done while the vehicle is in park or neutral. After maintaining this condition until the radiator fan engages, let the engine return to idle. Using the HDS, check the OBD status menu to see if DTC P0453 appears once again. If the HDS indicates a failed status, this confirms that the issue is duplicated, and you should proceed with further diagnostic steps. If it shows a past or intermittent status, the system may currently be functioning correctly, indicating a need to check connections for possible faults. Step 3 focuses on isolating the issue further by examining the FTP sensor's integrity. First, ensure the vehicle is in the off-lock mode before proceeding. Disconnect the FTP sensor's 3P connector to neutralize the sensor reading. Utilizing a jumper wire, connect terminals A and B from the FTP sensor 3P connector. Terminal A corresponds to number 1 and terminal B to number 2. With this connection established, turn the vehicle to the on position. Monitor readings for the FTP sensor using the HDS. The expected voltage should exceed 4.7 volts for 2016 to 2017 models, or show more than 27.23 millimeters of mercury for 2018 to 2022 models. If these parameters are met, it suggests that the FTP sensor is likely functional, and testing can proceed to check wiring continuity or further steps, depending on the results. In the fourth step of troubleshooting DTC P0453, we dive deeper into the wiring analysis. First, ensure the vehicle is turned off. Lock again before you begin any disconnections. Remove the jumper wire previously used, and then turn the vehicle to the on mode to activate the electrical systems. Next, measure the voltage across two specific test points of the FTP sensor 3P connector, namely the points corresponding to number 1 and number 3. Confirm whether the reading shows approximately 5.0 volts. If so, it indicates that the sensor's power supply circuit is intact, allowing you to move on to testing for any possible faults in subsequent steps. Should the reading differ significantly from this value, it signifies a need to investigate further into the source of the discrepancy, possibly looking for wiring faults or component failures. The fifth step involves checking continuity within the P-tank line, which is crucial for ensuring proper signal transmission. Begin by ensuring the vehicle is off, lock, and utilize the SCS line with the HDS tool to initiate a short and wait for more than a minute for a proper reset. Disconnect the PCM connector A, which consists of several key terminals. Establish a jumper wire connection between terminal 2 of the FTP sensor 3P connector and the body ground. With these connections properly made, check for continuity between the designated test points, terminal number 30 on the PCM connector and body ground. If continuity exists, the P-tank wire is operational, and it's prudent to check for any related service information for alternative DTC symptoms, or consider substituting with a known good component for further examination. In the final step, focus shifts to assessing continuity within the SG6 line, which is also crucial for system functionality. Maintain that the vehicle is in the off-lock position. Similar to step 5, jump the SCS line and allow for adequate time intervals. Disconnect the PCM connector A once again. You'll connect terminal number 1 of the FTP sensor 3P connector to body ground using a jumper wire. This allows for measuring continuity between the PCM connector's designated terminal number 20 and body ground. A successful continuity reading would indicate that the SG6 wiring is operational. If continuity is absent, this suggests a break or fault within the SG6 line between the FTP sensor and the PCM, which would necessitate repairs or replacements of faulty wiring to restore functionality. Once all troubleshooting steps for DTC P0453 are complete, conduct a final verification process to ensure that the issue has been resolved. Begin by clearing any DTCs using the HDS to reset the system. After clearing, take the vehicle for a test drive under various conditions to facilitate the reintroduction of potential faults. Monitor the dashboard and the HDS for any sign of the P0453 code reappearing. It is crucial to observe whether the check engine light comes back on during or after the drive. If the vehicle remains free of error codes, it indicates successful repairs, and the FTP sensor or circuit issue has been effectively addressed. On the other hand, if the DTC reoccurs, further examination and possibly repeated diagnostics may be necessary. Preventive maintenance is crucial for minimizing the recurrence of DTC P0453 in the Honda Pilot. Start by regularly inspecting the FTP sensor connections and wiring for signs of wear, corrosion, or damage, as these can lead to faults detectable by the diagnostic system. Ensuring the sensor is functioning correctly, alongside regular checks of the entire evaporative emissions control system, can prolong sensor life and maintain overall vehicle efficiency. It is also beneficial to adopt good fueling practices, such as avoiding overfilling, which can impact the EVAP system's functionality. Proactive measures not only reduce the likelihood of error codes appearing, but also promote sustainable vehicle performance over time, potentially saving on costly repairs. In summary, the diagnosis and repair of DTC P0453 relating to high voltage in the FTP sensor circuit involve a systematic approach to troubleshooting. Understanding the component's role within the evaporative emissions system is fundamental, as it impacts both vehicle performance and emissions compliance. Regular checks and thorough testing are essential to accurately diagnose and address the issue effectively. Preventive maintenance can be a game changer in ensuring that the sensor remains functional and free from problems, thus improving long-term reliability. Awareness of symptoms and potential causes allows vehicle owners and technicians to maintain optimal performance and respond quickly to issues, ultimately leading to a better driving experience. Please like and subscribe to the channel. See you next time.